A very good day to our lecturer, Dr. Khairul bin Kamaruddin. Today we are going to present on the topic of effects of different cooling channels on the cooling efficiency in the wax injection molding process. Let me introduce the group members. Me, I am Pavin, and my group mate Nur Hanis, and we will present accordingly. These are the contents in our presentation. The first one is introduction, where a light brief on the effects of different cooling channels on the cooling efficiency in the wax injection molding will be presented. Next is the literature review, where the opinions in the topic from researchers are presented. Methodology, where the steps on how the method were conducted. Findings will be the discussion on the methods used and how it were conducted. And conclusion will be a summary on our assignment, and lastly the opinion. Okay, so what is a cooling channel? Okay, based on the first point, this productivity can be improved determining by the dies or mold with conformal cooling channels. The technology that uses in this process is the additive manufacturing technology, such as the selective laser melting. The laser technology allows the manufacture of complex conformal cooling channels in the molds or dies. Okay, there are few types of cooling channels, which are conventional cooling channels, parallel conformal channels, and series conformal channels.
Now I will explain about the literature review. The most common method for the manufacture of plastic product due to its high performance and manufacturable. Three critical stages are used in the process of injection molding. First is the filling and the packing stage, the cooling stage, and the injection stage. Among these three, the cooling stage is very critical, as a good cooling channel design decrease cooling time, improve productivity, and minimize unnecessary defects such as sink mark, differentiate shrinkage, thermal residual stress, and warpages. A cooling channel design decrease cooling time, improve productivity and minimize unnecessary defects such as sink mark, differentiate shrinkage, thermal residual stress, and warpage. An approach of generating spiral channel for a conformal cooling system and conclude that the cooling channel derived from spiral curve almost do not reduce the coolant flow rate. Moreover, uniform cooling of mold will be done by 4 channels. 4 kinds of conformal cooling channel are available. First is conformal spiral cooling, conformal zigzag cooling channel, conformal scaffold channel, and Werner diagram type. Advancement of metal 3D printing technologies, the application of conformal cooling channel produced by solid preform production is becoming prevalent. The conformal cooling channel system is recognized as one of the best solutions to mitigate cycle time, differentiate shrinkage, and warpage defects on molded components. Optimal design for cooling channel has been developed by several researchers, which can boost the efficiency of the cooling system in mold. But the optimal design of the cooling channel in the mold has been limited by the relatively simple configuration of the cooling channel.
Now we will move on to the methodology. The first step will be the usage of SolidWorks software to process the design, where the models is drawn with the defined dimensions for the outer model, diameter, thickness, and length. Second is the measurements, where all the 4 molds have been measured. Then can proceed to the next step, which will be the third step, where it will be the arrangement of cooling channels, in which the arrangements need to be checked conforming to the molded materials. Next, cooling channels concept were taken to the fabrication utilizers, where such machines were used, which are 3-dimensional printing units. The fifth step will be the extraction of the support material using an alkaline detergent solution to extract the support material from the cooling channels. Sixth, the constructing the mold using liquid silicon rubber vulcanization to construct 4 model, as the coolant observation flow will be very visible in the cooling stage.
Next part I will discuss about the finding. sample of fabricates wax injection mold with series conformal cooling channel C has the easier to control velocity in each part of cooling channel. This is because of the comparable stream rates that will permit the warm move to get a portion, since the stream rate state is anything but difficult to keep up. The actual situation, a schematic illustration of the all sample. The sample of fabricates wax injection mold with series conformal cooling channel C provides a uniform mold cooling, making the cooling time shorter. The benefits of uniform mold cooling are the undesired defects can be avoided, but there is a greatest drop in pressure. The flow rates of fabricate wax injection mold with parallel conformal cooling channel B is reduced in each branch of the sample. It can then be used in a region of the mold that cannot be cooled effectively with the conformal cooling channel sequence C. As for the example of fabricate wax injection mold with traditional cooling channel A, due to non-uniform mold cooling, a longer cooling time will be produced. The surface temperature of the wax pattern as a function of the cooling time for cavity insert for all samples. The sample of manufactured wax injection molds with series conformal cooling channel C is the best sample with high cooling efficiency. It has the shortest time to reach the injection temperature. A function of a cooling time can be observed by the wax during the low pressure wax injection molding process. When a study of manufactured wax injection mold with series conformal cooling channel C was determined to the best candidates to minimize cooling time when it has been cooling flow rates of 16 liters per minute. Sample C has the most obvious increase in cooling efficiency with reduction in a cooling time 89.92%. improving the efficiency of a new product.
And now moving on to the opinions. The first one will be achieved by analyzing 3 sample forms with various channels of cooling. Next, the best sample of cooling channels was identified, making the outcome easier for the reader to understand. The rapid tooling is the best means of manufacturing for a new product in a short batch by injection molding in the research and development process. And for the conformal cooling channels, it was incorporated into the low pressure wax injection molding in order to increase efficiency. And lastly, the series cooling channels C were complied with, as it is the most efficient cooling channel in the wax injection molding process. It is the best sample as it is checked by all the evidence reported in its outcome, and all the reasons for this are mentioned explicitly in the discussion.
Now I will explain about the conclusion. Insufficient form with conformal cooling channel give a significant saving in the cooling session of roughly 89.92% constrained with non-cooling channel. The cooling channel stream rate has no significant effects on cooling time. The equal conformal cooling channel and conformal cooling channel arrangement are generally supported, despite the fact that the conformal cooling channel arrangement is emphatically suggested as an answer for improving the proficiency of the new item in the technique of insufficient forming.
That's all from us. Thank you.